So what do people want to do today?
The assignment.
Yeah.
Go over like a little more on classes.
On classes?
Yeah.
Okay. Well, I don't want to work out this assignment for you because this is, if I work out everything, you'll never have demonstrated to yourself. You're ready for the quiz. Yeah.
Do you have something similar to that, but just a little bit harder?
Yeah. Well, did you do this one?
Yeah.
And then the lab is done, right? So let's see. Let's look at the assignment here. Egg carton. So let's think of something similar to egg carton. Let's come up with something. And I'll copy from Lab 5. Oh. So here we have, we're going to practice with anybody have an idea for a class?
Maybe like try to do like a donut box.
A donut box?
Only put a dozen into the box.
Donut box? Yeah. Yeah, a dozen donuts.
Something like this.
That's like practically the same thing, isn't it? Yeah, same as the 12. Let me talk about this. Here's what the class looks like, and notice that instances of egg carton have two variables, brown eggs and white eggs. So when you implement this function, get total eggs, what do you do? What do you do in get total eggs?
Brown eggs plus white eggs.
Yeah, brown eggs plus white eggs, and you return that. So notice we don't have a member variable called total eggs, because total eggs is something that can be derived from information we already have, and we don't want to keep track of redundant information because it makes the program more complicated. Let's suppose we had 3 fields here: brown eggs, white eggs, and total eggs. Well, if we made a change to brown eggs, we would have to immediately make a change to total eggs. If we made a change to white eggs, we'd have to go and make a change to total. So we would have to keep our third variable, total eggs, in sync with the other 2 variables. So in programming, in software development, it's not a good idea to synchronize a data like that, which is dependent on each other. Now, if it turns out that there's a performance penalty to not synchronizing total eggs with the number of brown eggs and white eggs, like if it's a video game and you don't want to repeat this operation, every iteration of the game loop or something because it's too expensive computationally, then you would maintain that information, which is redundant, and we would just have to be careful to keep it in sync. But then it makes the program harder to maintain, because you just have to remember that if I have an operation that modifies one of the variables, I need to modify my total variable as well. So rather than sort of requiring that overhead, that we just implement get total eggs, by computing the value on the fly when the function is called. So when getTotalEggs runs, we return brown eggs plus white eggs. Is that clear for everybody? I know I'm just talking here. You can grasp it. The other thing about it is it's this egg carton is just a class. It's like a pattern. You can think of it as a cookie cutter. It's not a cookie. It's not an egg carton. It's a pattern for an egg carton. It's the machine that makes the egg cartons. It's when we go new egg carton and pass in the two arguments, brown eggs and white eggs. When we call this constructor, it says that, hey, we want to make an egg carton. And so we can call that constructor several times. We're going to make separate egg carton instances. And each egg carton can have a different number of brown eggs and white eggs. That's something you've got to keep in your mind. What about this constructor? Does everyone know what to do with that? So this is a function that runs that's responsible to initialize a new instance of the class. By the way, there's another word for instance of a class. It's called object. So when we create an egg carton object, it's this constructor function that runs. And it sets the value of brown eggs and white eggs. That's the reason we need to have those values passed in. We could define a constructor that doesn't take any arguments, and then we might set brown eggs and white eggs, say, to 0, or some other initial state, which makes sense for the problem that we're working on. But this is just a made-up example. We're not really solving a problem for a larger information processing system, so we don't really have requirements other than the requirements that I state here. So we're kind of looking at it out of context. But we need to do that just to see what this thing is in a kind of in a simple way. So, when this egg carton constructor runs, we have to, the brown eggs that are passed in here is what we set to our member variable brown eggs. And you'll see all of the code that I've presented so far is, all right, shows how to do that. Let's take a look at this school bus. It's it right there. You've got two variables coming in, and you just set their values. All of the constructors in our course will be like that. So the constructor is nothing. The constructor is trivial for you, hopefully, although it's hard for you to grasp what it really means and what's going on. And you need to continuously struggle with that till you really understand it. But when it comes to providing a solution, you'll just follow this pattern. Whatever arguments are passed in to the constructor, that's the data that we need to preserve inside the class. And we want to preserve inside the object. We want to modify the instance variables. So we use this to label an instance variable and distinguish it from a function parameter. See, it's just convenient. We gave them both the same name, seats. So it's unambiguous, where the seats needs to go. The seats being passed in needs to go to the instance variable by the same name. And that's a common pattern. You just see everybody pretty much sticks to that pattern. But we need a way to distinguish between the parameter and the instance variable. So we use this, you can think of it as an annotation or as a label. It's a pointer to the object instance. And that's a topic that's covered in the book in chapter 6, I believe. And we're not going to get to that chapter. That'll be covered in the the quarter that follows this quarter in that CSC 202. So that's the constructor is straightforward. If you look at the other examples that I presented, to get total eggs is not bad if you think about it. And then it has to do with these two functions, add brown eggs. And the thing, when you go to implement that, you have to, first, I recommend just do it in a simple way. Just add the brown eggs in there. If you've got 3 brown eggs and you want to add 2, just add the 2 in there. And then think about the restriction that you need to operate under. And that is that the total number of eggs, the brown eggs plus the white eggs, must be less than or equal to 12. So before you add the brown eggs into the brown eggs variable, so n represents the number of brown eggs to add. Before you modify the brown eggs variable, you want to check to see that the brown eggs plus the white eggs plus n, if you add them all together, that it's not more than 12. If it's more than 12, it's not going to work. So you return false and do nothing. But if the brown eggs and the white eggs and n, the number of brown eggs to add, if all 3 of those values added together is less than or equal to 12, then you know that it's not a problem, that you can increase the number of brown eggs by n and then return true. As remember, we're going to return a Boolean value here. So basically, I told you everything, almost everything you need to do to solve a problem. This is it's not a big problem, and you'll see for these it's just a few lines of code. It's not a big deal. I mean, it is a big deal. I know it's a big deal for you. I shouldn't be saying it's not a big deal. It's a new concept. It's hard to grasp. You know, it's not obvious. When computer languages were first kind of invented, there was no concept of a class. There was just, the functions came early. You know, there was a concept of a function. I don't know the history in detail, but functions have been around a long time as a way to separate chunks of code into units that have limited responsibilities so that you can reason about how your program runs. So you need to do that. You need to limit, you need to put things in compartments and then generalize about the compartment and say this compartment, adds brown eggs, and this compartment over here adds white eggs. And, the details are in the boxes, but we're just going to deal with those as boxes. And that's a function. The function is the box. The inside of the box is what the function does. You've got an input you're putting into the box and then an output where the result is coming out of the box. So that paradigm, that pattern was established early on and widely used. And then there was a point in time in history when this idea of user-defined data types came around, otherwise known as classes. And this is referred to as object-oriented programming. And then they had object-oriented languages and so on. And when this first came out, it was not obvious. It was almost like a religious war. People said, no, it's useless, it's confusing. Most of the programmers that were already established in their thinking couldn't quite grasp it. How, they've been writing code and solving problems without this organizational technique, and it was just hard to understand. There was resistance there. So it was many years. I mean, 10, 15 years, 20 years, something. I don't know what it was. So it was a long time when it was questioned about whether there was any use in using classes to help organize code. And, those questions have not 100% disappeared. There's still, you can still argue one side or the other. But in practice, in industry, everybody uses classes now. Everybody. If you're working in assembly language or C, those languages don't have classes. But if you're working in a language like C, then you're going to do something that makes something look like a class. And pretty much, the world and universe of computer programmers have basically learned at this point after, 1 or 2 decades of thinking about this. So it's interesting. So it's not, my point there is it's not trivial, it's not simple, it's something it just didn't exist before, and it exists now, but it's been widely adopted, and if you do anything related to programming, you've got to understand it. It reminds me of another event in human history, which is the number 0. I mean, there was a time when certain civilizations, like I think it was the Romans didn't have a 0, right? The Greeks, they didn't have a 0. They didn't have a concept or a notion of 0 as a value. I think in the Arab world there was a 0. And then the idea of a 0 came from, was the Ottoman Empire. So I don't really know the history, but I know there was a time, certainly in Western civilization, that there was no 0. I mean, doesn't 0 sound kind of simple and obvious, and it was taken for granted? But there was a time when people questioned whether it was, that's not a number. I mean, why would we want to even think about that? We're not going to use that in the way we reason about math because we're not used to it. We don't see the point. And the same feeling was there when it came to classes, maybe 20 years ago, 10, 15 years ago, something like that. And but the concept of classes and user-defined data types eventually sort of won everybody over because it's so useful. And it's useful for what? It's useful for building large, complicated systems. If you don't have a way to organize your logic in clear, easy to understand ways, you get lost, and it limits the complexity that you can manage when you're building an automated system. Anyway, so long lecture on that one. So, I don't just short from just showing you the answer, I don't think I can go any further. You really need to grasp the concepts and finish this particular exercise by yourself. But if you like, we can solve another problem, not a donut problem with, chocolate-covered donuts and sprinkle donuts. It would be pretty much identical, right? So I don't want to do that. How about anything, you want to think of another example? A number, maybe a school bus. Do we want to do that? The other thing we could do today, by the way, is to move forward, and that's what I was thinking about doing, and going into this lab 6 arrays. Well, I don't want to confuse people, but it would be the natural thing to do next. Do you want to spend more time in classes? Go through another example?
Yeah.
That's a yes on that? Okay. All right, let's pick something. Let's say we had, a house. We're going to model a house. And say there is, I'll call it house 1. And there'll be some information that we pass into house. And then we're going to use house in some way. Let's see. Let's think about that. Like how many people are in the house? How many children are in the house? How many adults are in the house? How about that? How about we do that? Let's do this. Let's How about if we have a house with say, no, yeah, I guess we could do a house. Say a house with 5 bedrooms. And let's do like something like this. We'll do house 1 dot get residence. And initially the house is empty. And then what we do is we add residents to the house. And let's add a resident, just add 1 resident at a time, say. How do we want to do that? I guess we can do add residents. We'll do it like that, just keep it simple. So 2 people come into the house. And that should be permitted because there's capacity for 5 people. And so that should be returned true. I mean, it's not a great example, but, because, a married couple would use 1 bedroom, so maybe I don't want to think of it in 5 bedrooms. So we have a capacity for 5 people, say. And so we're going to add 5 residents. So we add 2 residents. That should succeed. But if we add, say, 20 residents, at this point, that should be false. And the total residents should be 2. So there we're writing the test code first. So we have residents, we have a capacity, which is passed in here. In fact, we could also do we could also have a function get capacity or get max residence. Max residence should be 5. That's what we passed into the constructor. So the max residence won't change. That should always be the same. So we have this idea of a maximum number of residents and then the total current residents. And then if we create another house, say we'll call it house 2, and say this is a smaller house, then the max residents are 3, but we have to change this here. And the initial residents are always 0. But if we add residents, so we can add 3 residents, and then our total residents now are 3. So these are just test cases to see that our house is correctly implemented. Any other ideas on test cases? Does that make sense? We have here? All right, let's look at this house class. So the constructor, let's do maybe we can do the UML class diagram. Why don't we do that? Just make some boxes here. Oh, I didn't do it right. I meant to do that. So here's our UML class diagram. The class name goes in the top box. And then our member variables, the state that we're encapsulating, goes in the second section. So we have a capacity. We'll call it max residence. Let's call it max residence. That's easier than capacity, right? And then we'll have a residence. And max residence, well, it won't be a double, it'll be an integer. Residence is an integer. And these will be private. We won't expose those to outside code. That might not make a lot of sense to you right now, but so you don't, that's a point that you might get later on. So the instances of this class, instances of this data type, will encapsulate, will wrap these two integer boundaries. So we created, in our test code, we created two house objects. So each object has two integers allocated in computer memory to store this data. And now we have the constructor. And the constructor takes the max residence, which is an int, and then we have a number of functions. One is get max residence. That returns an int. And the other one is add residence. Add residence takes an int. We want to give the name first. So say residence to add. I'll use n because just so you see how to use an n. As in your assignment, there's an n in there. So n is the number of residents to add. And these need to be designated as public or private. We will make all of these public. That means our code in the main function can reference those three numbers. But code in the main function cannot reference these numbers. So code in the main function will not be able to access max residence because it's private. But it will be able to access get max residence or add residence. But we also had get residence too, right? Is it get residence? I think we have get residence. that right? Oh, yeah. So we have get max residence, we have get residence, and we have add residence. Those are the operations we want to perform on our model of a house. So we're modeling a house. We're modeling the, what a house means to us. Whatever particular problem that we're working on, a business problem, an engineering problem, a sociological study problem, whatever the problem is working on, we need to have a model of a house, and then compute with that model. That's what we're doing. All right. So this should be a comment. And here is the constructor. So it takes an integer max residence. And then we have these functions. Get max residence does not modify the state of the class, and therefore we can declare that as const. It does return an int. And then we have just get residence. That's similar to get max residence. Just take the max out. It also returns an int. Add residence does not return any value, so that's declared as void. It returns nothing. It performs an activity, performs an operation. It modifies the state of the object that it's called on, but it doesn't. It's not needed to return a value. We do not declare that const because it modifies the state of the object. It modifies one or both of the member variables. So this should be enough to get a compilation. Oh, almost enough. There's one thing missing in there. Huh? Oh, private. Yeah, that's right. Actually, there's more than one thing missing. Thank you. So let's have a private section. Thank you very much. That's, but actually we won't need this to get a compilation. What's missing there is the semicolon. And you'll see that the member variables aren't needed for main to compile. We have these two files now. We do not have house.cpp. All we have is the interface defined. So that should compile. If I compile only main.cpp. Oh, add residence has to return a bool, right? Sorry, I made a mistake there. That should return a bool. That's not a void, it's a bool. So this is whether the operation succeeded or not. Now that compiles. And there's the object file that's generated out of it. Now we won't be able to link it. If we try to compile, we get a linker error. LD is the linker. And it's saying the symbol is not found. These symbols, add residence is not found. The house constructor is not found. Get residence is not found. So you told us about them. And we believed you. So we generated our object code based on what you said about what the house class would look like. But when you want me to produce the executable code, I can't find those functions anywhere. And so those functions are undefined. Those symbols, those function symbols are undefined. So we'll need to create those. And let me do it like this. I'll copy house.h to house.cpp. And we'll edit house.cpp. I don't want to duplicate the Uml class diagram. One location for it is good enough. And we need to include house.h, the header file, and then we'll go ahead and implement these member functions. The first function that we implement is the house constructor. The next one is this get max residence. The name of the function needs to be annotated with the name of the class that the function belongs to. So we use that double colon symbol to do that. We have the class name, colon, colon. That's how those look. Now these return integer values. And the last one returns a Boolean value. So what I've done here is implemented these functions as stubs. Now when we try to build it, we'll include both compilation units on the command line for when we run the compiler. And it works. It works. It generates a.out. But let's do, before we run it, let's do a prediction. This constructor is defined. It does nothing. We pass a 5 into it, but we discard the 5. We do nothing with the 5. But it runs. It'll run. What about the next line? When we call get max residence on house 1, what does it return? Get max residence will return 0. This is called a stub. We haven't provided a complete implementation yet. So get max residence returns a 0. Well, that will not equal 5, so this assertion will fail. Make sure I have that saved. So that assertion that get residence, or was it get max residence returns a 5? Wait a minute. What is the get max residence? Yeah, that's right. That should return a 0, right? So that will fail. There it is. Get max residence 5. Not assertion is failing. Okay. So we need to implement this. Well, max residence is a member variable. We just want to return the value of that member variable. Now, if I try to compile now, we should get an error, compilation error, because this has not been defined. I need to put it in here. No, not there. I need to put it in here. Let's see how that fails. use of undeclared identifier max residence. Just like what we thought. There it is. Max residence is now defined. But the test will not run because we're not setting max residence in the constructor, so we need to do that. The instance variable max residence needs to be set to the max residence that's being passed into the function. Now that test should work. This function, this constructor now saves the value 5 into the variable max residence. And then when we call get max residence, we retrieve the value 5. It should match with the 5 we're comparing to. So this assertion should now pass. But what about the next assertion? Will that one pass or fail? What does get residence return? It returns 0, so that's going to pass. Get residence is still a stub. See? It's still a stub, and we're testing for 0. So this test code here will also succeed. What about the next line? Add residence 2. Will this assertion fail or succeed? Succeed because our stub returns true. It doesn't matter what we pass into it. And what about this assertion? Huh? That'll fail, yeah, because we're still returning true. We always return true. That's our stub. There's our stub right there. We always return true. So let's make a mental note that when we add the 20 residence, this is the first assertion that should fail. Let's see if that's the case. Just want to make sure I save that. I also need to make sure I save this. Okay. There it is, add residence 20. That fails. So just as we expected. And we're doing this right. Do you see how we're doing this? This process, by the way, is called test-driven development. So we write the test code first. We get our specification, what the house is supposed to do. And then before we implement the house class at all, we just write the test code for it. And then we watch it fail. And then piece by piece, we implement the missing functionality in the house class until all of the tests pass. It's called test-driven development. It's a very, it's in a kind of an emerging sort of pattern that developers are following. So when you go to apply for a job, say, I use test-driven development. You should say that, impress that employer. All right, so let's keep going forward here. Get residence, add residence is failing because it's always returning true. So sometimes we need to return false. Let's go ahead and do the logic here. Basically, add residence should do something like this. It should be, our current residence, and we're going to add to it n. Our instance, the residence, that's our instance variable residence. We're going to increase it by n. And then we'll return true. But that assumes that the total won't exceed the max residence. So actually, before we do this, we need to test that. So if residence plus n is larger than our max residence, then we have a problem. Otherwise, we add it in there and return true. You know, some programmers will write the code like this. They'll say, well, you know, here's the condition. This is the bad thing that could happen. We don't expect that to happen very often. It's not the normal expected flow of execution. But if it does happen, we'll just return false, and then we're done with it. And that the main logic that would commonly execute is down here. So we just leave it at this level. And you know, some programmers will like that, and others say, no, that's confusing. I can't read that. It needs to look like this for me. I need to see that in an else clause. And this has the same result. It's just that this is more readable for some people. So you decide what's more readable for you and what's more readable for the people that will be reading your code. You know, I like it the other way, but I write it this way when I work with other people because this is what most people prefer. All right. Now this is assuming that residence is an instance variable, but it's not yet defined. We need to add that. There it is. So add residence is there. Now get residence, well, this is such a simple stub. Let's just go ahead and implement that one. And look, I'm just writing residence because there's no naming conflict. Residence is a member, an instance variable, a member variable. Those mean the same thing. Member variable, instance variable. Well, not exactly the same thing, but right now they're the same thing. And so we can just write it like that. But if you want, you can remind yourself that it's an instance variable. It's a member variable of the class. It's an item of data which is inside of the object that you created. And you can label it as such using that notation. Yeah.
Does capitalization not matter?
Capitalization does matter. Am I making a mistake on that somewhere?
I think on int house get max residence, the m, one up.
Get max residence?
Yeah. Oh, is it? The m is capital.
Yeah, that's right. Yeah, so this is called Camel Case. So in the Camel Case notation, each distinct word inside the identifier is in uppercase. So you would read this in English. You would read get, space, maximum, we're shorting it to max, get, max, residence. It's 3 words, okay? But the first word, we start with lowercase because that's the naming convention for functions in C++, is to start with lowercase. But the words that appear, the second and later words that appear inside the identifier start with uppercase by convention. The compiler doesn't require it. It's the human readers that are expecting to see it like that. Does that make sense? It's called Camel Case. Do you think that's a good name for it? Like a camel, it's got humps. It makes it easier to read the name because you see the word boundaries. The alternative naming convention, which lost out, I want to tell you, although you still see it, but I would say, and I love this other naming convention, everything is lowercase, and you use underscore to separate the words to make it easier to read. But this is not the common naming convention that's used. This is the common one in C++, also C# and Java as well. C# and Java follow this naming convention, except in C#, the function name starts with an uppercase. So there's variations between languages. And you'll see there may be other languages that like to use underscore here. But this is you do see that sometimes, but that's pretty tough to read. That's really tough. So Camel Case is kind of the common pattern that people follow. You'll see it when you look up the API for the programming environment that you're working in. You know, let's suppose you're writing a Windows program and you're writing a game or I don't know some application, and they'll have something called an API, which is functionality which is available to you as a programmer, and you can access that functionality provided by your development environment. And you'll see all the names. There'll be a bunch of classes. They all start with uppercase letter. Then each class has lots of functions, and they all follow normally strictly follow a naming convention. Now, when you look at C++, the libraries for the C++ language, you'll see variation. You don't see a consistent naming convention followed there. So in the standard library of C++, you'll see classes that start with lowercase letters. But that would never happen anymore. Well, it hasn't been happening. With newer languages, that's been avoided. All right, so getting off there, maybe you're losing track of what we're doing here. Do you think everything is done? We've got our two-member variables. That's all we need, are those two variables. That matches the UML diagram up here. We have two variables. We have all of the functions implemented. They're no longer simply stubs. And this does return false, and this does return true. So I think we're good. All tests pass. We're done. Does this help? Yeah? Okay. You know, I got to tell you, what you need to do is you just got to do it over and over again. I mean, how did you get good at playing that video game? Huh? Did you watch someone else play it? I know that. My kids do that. They'll watch someone play a game first on YouTube, and then they'll sit down, but they got to practice. So if you're not practicing, it's going to be tough for you to do well in the quiz, and it's going to be tough for you to progress if you plan on taking more programming classes, which many of you are not planning on that. So I understand that. So you got to practice, just like I did today. Just create an example and just practice and get good at it, and then become second nature. And then it's a fantastic skill. I mean, it's a marketable skill. It's a skill that people are using to get work. So, I mean, it's worth learning. And I got to tell you, too, it's boring, when I'm in my lecture. I know it's boring here, but when you start doing this on your own, you can really get into it. I mean, it's fun. It's satisfying. So just, if you want to believe me on that, you can take that if you like. Is there anything else that you want to do? Because it's already pretty late now. I can start talking about arrays, or I can hold off until next time. Also, next time we're going to look at assignment 2, so we'll work through that solution. But that'll be fast. I think I can go through that in 20 minutes. Should we break, or do you want to do arrays? Who wants to do arrays? Nobody. 0. I should have bet on that one. Okay, that's it for today then. Okay.